So now turn to page 195, and this is 4.4 perpendicular lines. And we are not going to construct perpendicular bisectors and perpendicular lines, okay? We are just going to know what they are and what they do. So perpendicular bisector is not only going to be a perpendicular line, but it's also going to bisect the line segment A and B. So I'm going to draw a perpendicular bisector. I'm going to label it perpendicular. It makes a right angle. I'm going to call it line L. And because it's a perpendicular bisector, I know that this side is equal to this side. Now the other thing that we need to know that for any point P on a perpendicular bisector is also equal distance from either end. So this distance would be equal to this distance. So let's flip to the next page and look down here at number 3. What conclusions can you make about triangle JLK in the diagram using the perpendicular bisector theorem? Well, I know that KM is congruent to ML, don't I? And it says right there. I also know that for any point P, I called it P last time, on the perpendicular bisector is the same distance to either point at the end of the segment. So I know that JK is congruent to JL. And we're going to discuss more about that triangle in class tomorrow and what else you can discern from it. But think about what else you know about any of those angles too. And that is it for tonight. Have a great evening. We'll see you tomorrow. Okay, so today we are going to prove that lines are parallel. And the way that we do this is that we use the converse of theorems that we already know. All right, so if you turn to the next page, and it says here in Explain 1 about converses. Okay, remember last time in that section, we would say if we have parallel lines, then the same side interior angles were supplementary. If we have parallel lines, then alternate interior angles are congruent. If we have parallel lines, corresponding angles are congruent. Well, the converse says the opposite. If two lines are cut by a transversal and the same side interior angles are supplementary, then the lines are parallel. So you can go backwards with these. And if you turn the next page to 187, and we look down at your turn, we're going to do this. So it says, explain why the lines are parallel given the angles shown. Assume that all tile patterns use this basic shape. And they're talking about this shape right here. Okay, so 1 is 120 degrees. Okay, and 2 is also 120 degrees. So if the measure of angle 2, or if angle 2 is congruent to angle 1, then lines 1 and line 2 are parallel. And we can use this symbol right here for parallel. Okay? So number 5. Line 1 is 120 degrees. Angle 1 is 120 degrees, and angle 2 is 60 degrees. Those are supplementary. So same side interior angles are supplementary, then the lines are parallel. And so that's how we prove that, just as easy as that. And that is what we're going to be doing in class tomorrow.